Okay, so the real topic for the day is called discriminant, like discrimination. I'm just kidding. So the topic is discriminant of a quadratic equation. Discriminant of quadratic equation. Now, why is this important? It is important because it helps us determine the type of equation, the type of solution that a given quadratic equation might have. Discriminant helps us to determine the type of solution a given quadratic equation might have, even before solving it. Now the question becomes, what is this discriminant? That's what I'm about to tell you now. Now, remember, when we used completing the square, we determined that after using the completing the square to derive the quadratic equation formula, we determined that x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. This is your quadratic equation formula, which you have used over and over again. And this formula was derived from ax squared plus bx plus c equal to 0. So now, when you look at this formula, this formula, when you look at it, there is a special expression inside this radicand, inside this radical sign. And that expression is b squared minus 4ac. So this b squared minus 4ac is called, it has a special name that is given to it. It's called discriminant. Just this expression, b squared minus 4ac, is called discriminant. So now, why is it important? It is important because it is going to help us to determine if we have real solution, if we have one real solution, or if we have two non-real solutions. You know, remember, there are times when you have two different numbers. There are times when you have only one number. And there are also times when you have complex numbers. All right. So now let's define some of those scenarios. So now, if I'm going to use this with a different, if b squared minus 4ac is greater than 0, if it is greater than 0, then ax squared plus bx plus c has two real solutions, has two real roots.
Is that an 8x squared? Then 8x squared plus bx?
Yeah, that's ax squared plus bx. This is plus bx. Ax squared, which is the original equation of a quadratic. So if the discriminant b squared minus 4ac is greater than 0, then this quadratic equation has two real roots, real with a real number without a negative in it. That means we can actually find the square root even if we use our calculator. On the other hand, if b squared minus 4ac is equal to, if it is equal to 0, then ax squared plus bx plus c has one real root. one real root. One real root means something like square root of 16, which you can easily take to give 4. All right? Now, if on the other hand, if b squared minus 4ac is less than 0, it's less than 0. This is actually when you have a negative number inside a square root, and this is when you have a complex number. Then ax squared plus bx plus c has two non-real roots. This is just a fancy way of saying complex number. All right? You got it? All right. So now how does it relate? How does it relate? So now let's use any number. Let's use any number. You want to give me your own equation? Let's work with your own equation. Just give me any quadratic equation of your choice. Let's try it. Given, yeah, go ahead. Let me just use the one that was given to us earlier on. So the one that Rankin gave, which was x squared minus 9x plus 18 equal to 0. All right. So now remember, this has to be in form of ax squared minus plus bx plus c equal to 0. That means, considering this equation, a is equal to 1, b is equal to minus 9, and c is equal to what? 18. So now let's consider the discriminant. So discriminant is using b squared minus 4ac. That's the discriminant. So our b is negative 9. So you have negative 9 whole squared minus 4 multiplied by a is 1 and multiplied by c is 18. Multiplied by 18. So what does that give us? 9 squared is what? 81. Then 4 times 18 is what? 4 times 18 is what? 72. So 18 minus 72 gives us what? Gives us 9. Now, this means b squared minus 4ac is equal to 9. Now look at this condition. Is 9 greater than 0?
Yes.
Yes. So if it is greater than 0, you can conclude that you are going to have two real roots. That means when you take the square root of 9, if you come back to this your equation, the one we were solving, you are going to have something like solution x equal to plus x equal to negative b plus or minus square root of 9, all divided by 2. So square root of 9 is 3. So you are going to have plus 3 and minus 3. That's the two real roots. So you are going to have plus 3. So you are going to have negative b plus 3 over 2 and negative b minus 3 over 2. Two real roots. Once it is greater than 0, you are going to have two real roots. That's what that means. Okay? So now let's consider a situation whereby